Hello students, welcome to lecture 8th. Okay, so today we will go for the next. So in the previous video we have completed the cyclic voltammetry. Okay, so we have seen the cyclic voltammetry, on which principle it works, its working, how it works. Okay, then its application, what are the application of the CV. So these all things we learned, and with the example of potassium, ferri and ferrocyanide. Okay, so I hope you understood the cyclic voltammetry. And if any questions, if we see in the CSIR net examination, competitive examination, so I will go through, and if I get some questions on net examination, competitive examination, net set or gate examination, so we will discuss that questions surely after the completion of this chapter, unit 3. Now next concept in this is the your stripping voltammetry. So this is the next concept kept in your stripping voltammeter or metry in your syllabus. Now what is the stripping voltammetry? This is the basis of this technique is the electrochemical, I will write here, electrochemical pre-concentration, okay, pre-concentration of active species, of active species at the electrode surface, at the electrode surface. So this is important. It's nothing but this depends stripping voltammetry. The basis of this technique is nothing but the electrochemical pre-concentration of active species at the electrode surface. Okay, and its subsequent and its subsequent electrochemical removal from electrode, subsequent electrochemical removal from electrode. This is very much important. Okay, so pre concentration of the active species at the electrode and electrode surface and its subsequent removal, that's what stripping. Removal means what? Stripping from that particular electrode, okay, is called stripping voltammetry. Now it is a physical process, I will write here, it is a physical process. Okay, it's a physical process of separation, this is important, of separation in which one or more compounds, in which one or more compounds are removed, that is stripped, removed from the liquid stream, removed from the liquid stream by using the vapor stream, by using the vapor stream. So this is what important here. Now it has a low limiting of deflection, it has low limiting deflection, it has a low limiting deflection, and its concentration is also low, and it is a slow process, it is a slow process, and enables to obtain multi-elemental determination. So we can see multi-elemental determination can be done by this process. Okay, so this is what. Now the principle of this is, now if you see, the principle of this process, that is stripping, is of two steps. Okay, this is made up of two steps here. The first step, step 1, you can see that here the electroactive species, in the step 1 here, the electroactive species, okay, the electroactive species is pre-concentrated CuNCT, and deposited on electrode surface, and deposited on electrode surface. Okay, so in step 1 we have to see that the electroactive species is pre-concentrated and it is made to deposit on the electrode surface by by controlled potential electrolysis. Okay, so for this you can see mercury is the electrode, Hg is the electrode. So this is how the step 1 we do it here. And in step 2, so in step 1 deposition we do it here by concentrating the pre-concentration or by the electroactive species. And in step 2 you can see the deposited material is stripped here. So whatever in step 1 deposited material is there, deposited material or component is stripped or removed, is removed or stripped. See here. Okay, so it is removed or stripped from the electrode, whatever is there from the electrode. So whatever deposition is taking place in unit 1 here, so that is removed in unit 2 by the same process. Then the resulting the current used. Okay, so this stripping step I can say here, so which is removed from the stripped back from the electrode. Okay, in step 2. And this stripping step carried out by potential scan, this is very much important. Potential scan, whatever the stripping work we are doing, it is the stripping step is carried out by the potential scan. Okay, then the resulting current used to determine the resulting current used to determine the concentration used to determine the concentration of one or more component here. Okay, so this is the important here. So whatever step 1, step 2 stripping step which is carried out by potential scan, and then the resulting current used to determine the concentration of one or more current. So this is how we do it. Simply we can say that the deposited step can be, simply we can say that the step 1 deposited step can be deposited step can be the cathodic in nature. Okay, so it can be cathodic process. This can be cathodic process because we know that the reduction takes place and the metal is in the elemental form and gets deposited. So that's why we can say it as a cathodic process here, deposition process, where the metal ions are replaced, whatever the metal ions we are taking in analyte are reduced to give amalgam, because mercury is there, so it is going to form the amalgam and get deposited. And we can see the oxidation here. Okay, the oxidation, that is a gain of electron. So when reduction is there, oxidation is also the possible, where there is a gain of electron. So here you can see reduction, so mn plus n number of electrons, and you get here metal which is in the electrode, that we call in the form of amalgam. Okay, so this is what. And the removal step is the anodic deposition. Anodic, that is your deposition or process, where mercury is oxidized to Hg plus. Now oxidation, anodic process, where this amalgam formed in the previous deposited process now will get oxidized to metal ion, and you can see the number of electrons is been replaced, and this is going to be oxidized to Hg plus here. Okay, so this is how the oxidation and the reduction takes place in these two steps. So here cathodic process, and you can see here second step anodic process is going to take place in this way, where cathodic process we can see reduction and anodic process we can see oxidation. Okay, so this is how the process takes place in the stripping voltammetry. Now if we go for the next concept of the stripping voltammetry, the types of electrodes. Okay, so if you see the type of electrodes, mostly mercury amalgam, so Hg amalgam is used as an electrode. This is important. Okay, which is highly purified. This should be highly purified. This is important. Mercury amalgam electrode, this is electrode. Mercury amalgam electrode should be very purified, and this is made by a fresh drop of mercury. Fresh drop of Hg is taken. Okay, fresh drop of mercury is used each time. So it is used each time for each stripping process. Each stripping process, fresh drop of mercury is used for each stripping process. And if you see the size and area, you can see the size and area, okay, of the drop is controlled by limited value. So drop size and area of the drop of mercury amalgam is controlled by the limiting value. Okay, it's controlled to a limited value here. Also, the large number of solid electrolyte. So you can see along with this, the large number of solid electrodes. Large number of solid electrodes. Okay, along apart from this mercury here. So as gold, platinum, silver, or sometimes carbon electrode can be used. Okay, and these solid electrodes used when particularly when the area where the metal ion deposited is small. When the area where the metal ion to be deposited on this electrode is small. So during this you can see the solid electrolytes can be the best choice here. Otherwise the dropping mercury drops is a very good selected electrolytes. This is what you have to see in the type of electrodes. Okay, now if you see the types of this stripping voltammetry, so the two types as we have discussed in the previous discussion, then easily we can say that it can be of two types, that is your anodic stripping voltammetry that we called ASV, and cathodic stripping voltammetry, that is CSV. So these are the two types of stripping voltammetry here. Now one by one, simply if we try to understand ASV, that is anodic stripping voltammetry, here the cations in a small amount is determined. Cations in small amount in the presence in the analyte is determined here in this ASV. Okay, the pre-concentration of the metal, whatever, because this is very small amount, you have to go for pre-concentration. So the pre-concentration of this metal ion, the pre-concentration of the metal ion is achieved by reduction of metal ion. How this is achieved? This is achieved by reduction of metal ion. The pre-concentration of the metal ion, which are very small amount, is achieved by reduction of the metal ion to their elemental form, and deposition of metal ion is done on the electrode. So this is important. Okay, the pre-concentration is done by cathodic deposition. This pre-concentration of the metal ion is done by cathodic okay, deposition is done by cathodic deposition at a controlled time and potential, at controlled time and potential, at a controlled time and potential. The metal ion reaches the mercury electrode. So whatever we have pre-concentrated this metal ion, okay, so it reaches the electrode here. So the pre-concentrated metal ions now reaches the mercury electrode here, which is a mercury, and by the diffusion process it reaches here at the mercury. Okay, and at the electrode they reduce to form amalgam, and here they reduce to form the amalgam. As we have shown previously, the metal ion plus, after reduction here in the presence of mercury Hg, so what will happen here? Anodic strip is going to happen here, and you are going to get metal with mercury, that is amalgam is formed. Amalgam is been formed, and if this is the anodic stripping here, so we can say this is as a cathodic deposition. This is called as cathodic deposition 2. Why cathodic deposition? Because we are reducing this metal ion, and then we are depositing in the mercury electrode in the form of amalgam. So that's why if we say this is the anodic stripping, So simultaneously this is a process of cathodic deposition here. So this is what going to happen. This process is going to happen in the ASV here. Okay. Thus this type of stripping technique is useful. Now this whatever we have learned, stripping technique is useful where it is useful for those metal ions. It is useful for those metal ions which form the amalgam. This is important, which form the amalgam. So not all metal ions, but only those metal ions which is going to form amalgam with mercury suits are very good for this type of ASV. So some of the metal ions like copper plus 2, Pb plus 2, cadmium plus 2, zinc plus 2, etc. So this forms the best amalgam related form, and you can see they are going to be working very good well here in ASV. Now if you see the diagram here of the stripping voltammetry, you can see, so this is how you get this diagram, the chart here curve something like that, and it is been showing that how they can be stripped so different metal ions. Like here you can see this is of your copper, this is the lead, this is your cadmium, and this is your zinc, like this. Okay, so this is how we get the diagram here, and this stripping voltammetry diagram whatever we have got here graph, it is called as voltammogram, as we know, voltammogram. So where we can see the hanging mercury drop electrode is used here. So hanging mercury drop electrode, this is used here in experimenting this here. Okay, now here the simultaneous detection and determination of four common ions or four metal ions is done here, the simultaneous detection. So this is very much important, the simultaneous detection of these four metal ions four common ions can be done here, and has been made possible by the presence of the four distinct peak here. So you can see here the four distinct peak you are going to get here. Okay, and here the height of each peak. So if you see the height of each peak here, whatever the height we are going to get here, the height of each peak is proportional to concentration of this metal ion. Very important here, whatever the height of each peak we are going to get from this graph is proportional to the concentration of the metal ion present, and this is how the concentration of metal ion we can determine from the analyte here. Okay, and the concentration of this metal ion in amalgam, concentration of this metal ion in amalgam is given by Faraday's law, which stated that C is equal to I minus I of D divided by NF into V of Hg. So what is this I? This is nothing but the ionic concentration after and before the ionic concentration after and before concentration after deposition, after and before deposition. So this part. Okay, and what is here, V is nothing but the volume of the volume concentration, okay, of the Hg, and you know this, what is this is Faraday's constant. N is, you know, number of electrons, and F is Faraday's constant. So this is how the calculation is done, and the concentration of the unknown metal ions or in the analyte is found out by, and this process we call it as the ASV, anodic stripping voltammetry. Now the second one of this is CSV, that is your cathodic stripping voltammetry, and this is also used to determine the insoluble mercury salt. It is used to determine the insoluble mercury salt, okay, on the electrode surface, okay. So during the pre-concentration step, here the anions like halides, X minus like sulfides, okay, halides or sulfides or thiols, etc., can be determined. I can say can be determined here. So it is just like 2Hg plus X minus, you give Hg2 Xo. So that is what? Hg2 X2 and 2 electron above here. So this is how in cathodic stripping voltammetry we can go for this determination. So in this reaction, whatever we have seen here, the stripping is achieved by oxidation process. Reverse of that. So in ASV we are getting stripping by anodic process, cathodic process, reduction. So here we are getting in this reaction, stripping is achieved by oxidation process or oxidation reaction. Here in this subsequent stripping reaction, the stripping is achieved by potential in negative deviation. So here the stripping is achieved by potential by negative deviation. This is important. Okay, oxidation means negative deviation here. Okay, direction you can say. So this cause reduction of salt. So when you do this, this causes the reduction of salt. Okay, these anion may be stripped. Now these anion may be stripped in a way similar to ASV, what the previous we have seen, that is anodic stripping voltammetry. So similar way these anions can be stripped out in this case also. Okay, so the height and of the reduction peak here, so whatever in that also we have seen the height of peak there. So here also the height of the reduction peak, whatever we are going to get, is proportional to concentration of anion. Mercury electrode can be used for determination of this anion. Or here there we have used mercury here. Here silver electrode can be used. Okay, in this case silver electrode can be used for determination of the anions. Okay, determination of anion which is insoluble in, which is an insoluble silver salt. Okay, which forms, I can say, anion which form insoluble silver salt. This is important. This formed insoluble silver salt. Now this CSV, that is the your cathodic stripping here, is used to measure wide range of inorganic and organic compounds which are capable of forming, important thing, which are capable of forming insoluble salt. This is important, which are capable of forming insoluble salt. Okay, now the pre-concentration step is important here. Okay, in the step of stripping voltammetry. So here in this, the ion to be analyzed is extracted from the solution here and deposited on electrode as a metal or insoluble salt here. So here the pre-concentration step is very important. Okay, and the step of stripping the stripping voltammetry. So in it, the ion to be analyzed here, the ion to be analyzed, this is important, ion to be analyzed is extracted from solution, and deposited on electrode as metal or insoluble salt, So this is what about the ASV and CSV, that is your anodic stripping voltammetry and cathodic stripping voltammetry. So in this anodic stripping voltammetry, that is your ASV, is also called as inverse polarography. The ASV also called as inverse polarography, which is related to linear scan polarography. Okay, so this is what is very much important, and we have seen what electrode we have taken in this ASV and what about CSV. In a very brief way we understood today what do you mean by the stripping voltammetry. Okay, and its principle, its working, and you can see this the types of the stripping voltammetry, and the very brief way how the graphical this separation takes place here, and the Faraday's law of calculation here of concentration, So like this, and I hope that this is sufficient in this video to get a brief introductory part of this stripping voltammetry. Okay, so in the next video, if I get more on this, some points important on this stripping voltammetry, surely I will include in the next video. So hope you understood this. Thank you.